Okay, now for example 3, for using the complete the square method here, we're going to look at specifically an example where we still don't have a leading coefficient yet, but instead of this term being nice and even, it's an odd number, which kind of makes things a little bit more difficult here. So recall what we did with this number to complete the square is we half it and square it. So you notice that odd numbers, they don't half evenly, and so that presents a problem. So most of the time, if I have a choice right here of completing the square versus, say, the quadratic formula, I would definitely go with the quadratic formula so you wouldn't have to run into this. But just in case you do have to complete the square with it, let's look how you would do that. So again, I don't have a leading coefficient. If I do have a leading coefficient, we would divide it out first, and we'll see that in example 4. So now, let's take care of the 9 right here, and let's take it over to the other side. And so we're going to add this mystery number here that's going to complete the square. So the 9 is coming over. Again, I'm subtracting 9 on both sides. And whatever I add here to complete the square, I also have to add over here. So we mentioned earlier that we take this value and we half and square it. And since we square it, the negative really doesn't matter. But you can't really half 7 too well. So what happens here is we have to say half of 7 is 7 halves. Okay, so let's think about that. So we're going to take 7 and we're going to half 7. So 7 divided by 2, or half of 7 is 7 halves. Okay, that's basically all you have to do to half a number that's an odd number. You just put that number over 2 since it doesn't divide evenly. So half of 7 is 7 halves. Now we want to square that value. So when we take this number, we half it, and we square it. So when we square a fraction like this, what you're just going to do is you're going to square the numerator and the denominator. So 7 squared is 49, 2 squared is 4. So this would be 49 over 4. Okay, now I'm going to add the same thing over here to 49 over 4. So since we have fractions here, that obviously that kind of makes it a little bit more difficult. Now let's factor this into a perfect square trinomial. So this is something where you pretty much have to use our shortcut for the perfect square trinomial. And that shortcut here is just to take the square roots of both of these values. So the square root of x squared is just x. And then we're going to use this sign. And then the square root of 49 over 4, just do the numerator and the denominator. This would be 7 halves. Now, let's add negative 9 plus 49 fourths. Now I'm going to use my margin here to kind of do this. So if I'm adding and subtracting with fractions, I need a common denominator. So if I think of negative 9 as something over 4 here, this would just be negative 36 over 4, because negative 36 over 4 is negative 9. Now there's a shortcut into doing that. When you're doing a whole number, or an integer in this case, really all you have to do to get this common denominator, was to what goes right here, is just to multiply those two things. Negative 9 times 4 is negative 36. And now I can add those together there. So we get negative 36 plus 49 over 4. Of course, my denominator is going to stay a 4, which is nice because it'll be a perfect square right there. So let's see, I believe that would be 13. Negative 36 plus 49. You can really say 49 minus 36, so that would be a 13. Okay, so certainly, if you want to use a calculator, that would be a good idea right here. You certainly don't want to use mixed numbers though. Okay, keep everything in an improper form. Now everything else is just pretty much the same. What will usually happen here, you'll usually get a perfect square in the denominator. So I would advise against reducing this if you could, because you don't want to reduce out of having a nice perfect square in the denominator. Now we're going to take the square root on both sides, just like in the other examples. So that square root will undo there. And now since I'm doing the square root on both sides, remember what I can square to get this would be a positive or a negative. Now 13 is not a perfect square, so we're going to leave it alone. It's going to stay inside of a square root. But the square root of 4 is going to change into a 2. Okay, now I'm almost done here. So all I have to do is transpose this over. In other words, we're going to add 7 halves to both sides. So we'll add it, therefore it's going to be a positive 7 halves, and then plus or minus the square root of 13 over 2, which is certainly acceptable here. Now a lot of times you may see this written with a common denominator. Since both of these are 2's, we could write it this way. We could say 7 plus or minus the square root of 13 all over 2 there. Okay, so there's an example with an odd linear term. The next example here, we're going to look at what happens when we have a leading coefficient.